So this is a solar distillation unit. The fresh water is necessary for all the human life. So it is generally observed that in some of the arid, semi-arid and coastal areas which are thinly populated and scattered, one or two family members are always bring the fresh water from the long distance. So in this area, the solar energy can be used for converting saline water into a distilled water. The pure water can be obtained by distillation, which is a simple solar still, is known as the basin type. So here a figure shows that some of the solar system they are used for the two different type they are used normally. That is a double slope covers. Yeah, shows that is a double slope covers. Another one is having a single slope cover. So in a such solar still have been operated for a farm and community use several countries. It consists of black basin coating with the containing with the saline water with a shallow depth, over which is transparent of tight covered glass for entire basin. So it is like a uh, roof like shape. So the cover, which is usually a glass or maybe using as a plastic material, glass or using as a plastic material, is a slope toward the collection trough. The solar radiation passed through the cover is observed the uh, solar observed and converted the heat in a black surface. The impure water is basin heated and vapor produced and condense the pure water on a cool interior of the roof. The transport of the roof material, that is transmit nearly all the radiation falling absorbed as a little, hence it remains cool enough to condense the water vapor. The water flow, condensate water flows down. Uh, that is a condensate water flows into the down of the trough collectors, and the saline water can be replaced in a by the replaced in the operation by either continuous operation or otherwise a batch type operation. So there are numerous configuration of basin type of unit. For all the basic theories for identical for same for the or the entire uh, uh, type of the distillation unit. So the product is lower than the other type of solar equipment. So only the operation. So the operating efficiency is up to 30 to 50% of the basin type of solar cell efficiency. Basin type of the solar cell efficiency. The performance of efficiency is shown to be here. That is a W into del H with by the H, where W means that is a weight of the distilled water per square meter per day. Del H is nothing but enthalpy change from cold water to vapor. So H is the solar radiation intensity per square meter per the day. So the performance of the solar still is generally expressed quantity of water produced by each unit of the basin area in per day. So the thin quantity of will vary. Design of the solar steel, which intensity of the solar radiation, and with the atmospheric condition is surrounding. The production rate depends primarily on the amount of solar radiation available, but is affected by the several other factors like ambient temperatures, wind speed, atmospheric humidity, like solar condition. So the effect of design parameter such as a orientation of still, otherwise cover sloped covers, that is a single slope or double slope covers, uh, with the inclination of glass covers, that is the angle of inclination, insulation some of the base of the insulation material we can use some of the information. This factor to be affected the converting parameters. So the normally the solar still insulation may be provided up to 15 to 50 liters per day for the 10 square meter area. If increasing this square meter area design of the collector area, then can increasing the output of the pure distilled water. It can be used for the distilled waters. So next one is that distilled waters. So next we have some of the advantages means it have the easily maintenance is easy. It can be transport from transport one place to other place. It can be taking for transport to one place to other places. That is a cost wise it have very simple construction. So maintenance is also very less maintenance is also there. So other some of the disadvantages means, so it have required for collecting the conversion process is a very low. It will be taking is a more area is required for into the converting percentage. That is a converting of what distilled waters. It requires the more area is required. So the solar pump consists in utilizing the power generated by solar energy for water pumping for useful agriculture purpose. The solar energy have offered several features for utilization of irrigation purpose, agriculture pumping the attractive method. So that is the number of method presently are used as a used for the solar pumping system. So with the PV panel and likewise we have used for number of system modern system we have used for solar pump system. So we have connected now we have discussed on the conventional or a traditional solar pump system. So it have consist of a number of component to be used to be here. First one is a solar collectors. So the collector consists of number of different type of collector we can use. So there is a flat plate collector or solar pond or stationary concentrators and sun tracking system. That is a different type of solar collector we can use. And second one is a heat transport system. And third one is a boiler and heat exchangers. And next one is the heat engines. So heat engine we can use for different type of heat engine system we can use. That is a Rankine system, Rankine engine or Stirling of hot engine, Brayton cycle and rotary piston engine, or otherwise we can use for turbine also we are used for the heat engine system. Next one is we can use for the condenser. So last one is a pump. The pump we can use for different type of pump we can use. That is a reciprocating type of pumps and a centrifugal type of pump and a diaphragm type pump we can use, and a rotary type of pump we can use for this. So this is the diagram to shows a basic principle of solar pump system we can use for the solar pump system. So here we are using for the solar collectors, that is a heat exchangers, another turbine and pump and condenser, another one pump used for recirculating system. So this is the pump used for sucking of waters from the below the well or otherwise suction below the well. So this is the different type of component to be used for the solar system in the normal system generally used. So then this is used for, that is a solution, that is a Brayton butane solution to be used for the for that is a conversion system, that is a converting to the system expanded system to be used a Brayton solution, that is a butane system to be used for butane. That is a collector. Generally, that is a collector. The primary component of the system or array, a flat plate collectors and Rankine with organic fluids as working system. During the operation, the heat transfer fluid flows through a collectors. Depending upon the collector configuration, a solar flux and the operating condition of the engine, fluid will be heated. The collector with high temperature, the solar energy is converted into the thermal energy. The water flows into a heat exchangers, that's like as a boiler due to the temperature gradient, and compact in the collectors. So the water yield of heat and intermediate fluid of the boilers. The fluid is evaporated and expand in the engine before that reaching the condensers. This is the fluid to be expand in the condensers, expand in the turbine, and and the condenser to be condensers. So the condenser cooled by the water be the pumped. The fluid then re-injected to the boiler to the closed cycle. The expansion of the engine is coupled with the pump and and could be like I say electrical generator, like I say electrical generators. The pump to be sucking of water from the well level and sent to the irrigation purpose or agriculture purpose. For the efficiency of the pump to be collectors to be managed for the product of the collector efficiency and product of engine efficiency, that is both engine efficiency, collector efficiency to be calculated for the pump efficiency. If the higher temperatures in a boiler result as an higher engine efficiency, but in a higher temperature at a boiler requires high temperature for record is collector temperature is record, which decrease the collector efficiency. So there is the optimum range of temperature for the solar pump system, which result the maximum efficiency of the system, So it having that's a number of working fluid we can use for the irrigation, used for the recirculation system. Number of pump fluids, organic fluids we can use. So generally that pump capacity for that rated speed is a 90 kilowatt. 90 kilowatt, it will be delivers for 30 to 32 liters of liter per second from the 30 mm, that is approximately 30 mm deep. So the energy efficiency of the percentage of solar energy collected, the converted to the useful work up to, that is a 13 to 14%. It is a low value, but if you increases that efficiency, means that is a improvement of the collector to be increases, and that is an Rankine cycle efficiency will be within the acceptable limits if the temperature must be required for 200 to 400 degrees Celsius is required with the proper functioning of the collectors. So having some of the advantages of solar collectors, solar pump. So that is no need for the electrical requirement of the no need for more amount of electrical energy, and it will be used for converted in the solar energy. So this is simple construction is a very simple, and it will be major disadvantage of the major so for the solar pump. Only for the efficiency is very lower efficiency, conversion efficiency very low, up to that is a 13 to 15% only the efficiency. Now we have discussed on the solar dryers. So normally the drying of the food is necessary to store it for a long time. That means harvesting and consumption. In between the harvesting and consumption, the high moisture content in the food spoil due to the fungus formation during the storage time of the harvesting. So this problem can be solved by drying of carp with the optimized moisture content. The dried carp can be used for long period after the storage. So the dryer can be mainly divided into 4 categories. So open sun drying system, direct drying system, indirect drying system, and a hybrid solar drying system. That is a 4 category they are used by the solar drying system. So the first one is that is a open drying system. So that is a diagram open drying system as shown in the figures. So it is a simpler system, still widely used in a rural part of our nations. In this system, crops or seeds are spread on the open surface. There is direct sunlight and direct sunlight, and the short wave length of solar radiation falls uneven crops of surface. A part of energy is reflected to the edge, reflected to the back. Remaining part is absorbed by the surface crops depending upon the color of the crops. So the absorbed radiation is converted into thermal energy due to the temperatures of crop start that increasing. So the result of long wave radiation converted into heat losses due to the blowing of wind losses from the surface of crop to the ambient air. The crop is dried due to evaporation of moisture takes place in the form of evaporation losses. So further, a part of absorbed thermal energy is conducted into interior part of the interior of the product. It causes the rise of temperature of the corp. Further, it's for the drying. So in this type of drying system, there is considerable loss due to the various reasons such as random bird, insect, and microorganism. So the unexpected rain or storm further worseness of the situation. There will be further damage of the field crops, may be possibility of over drying or insufficient drying or contamination of the crops such as dust or dried and insect. So next one is that is some of the demerit of the open system. So it is a traditional method of drying and it is not as a faster. The product are contaminated by the dust or insected by the birds. The dried product are not clean and less hygiene. So drying is achieved only as sunny days. We are not used for the winters, not suitable for the winters. So that is a drying is not proper, and there is a loss of nutrients. The space requirement is higher and profit margin is lower. So next one is the direct solar energy system. So that this is the arrangement shows to be here. That is a direct solar system. It is referred to cabinet dryers. So in this system, the crops are spreaded inside the chamber base, having a metallic or net frame which is covered by the transparent glass cover. As the air vent is provided, so one side of the chamber to facilitate the escape the hot air and moisture. A part of instant solar radiation on the glass cover reflected and absorbed, reflected back to the atmosphere. So remaining part of the solar radiation are transmitted through the glass cover, by the observer, by the crops. So it glass cover is further the part of transmitted radiation reflected back from the surface of the crops. So the rest of the part absorbed by the surface of crops. Due to the absorption of radiation of the crop temperatures, increase the crop start emitting the long wave radiation. So it is not escape to the atmosphere due to the presence of glass cover. So unlike the open sun drying system, so such temperature above the crop inside the chamber become is higher. So next one is a indirect drying system. So this is the arrangement as shown in the figures. Indirect drying system as shown in the figures. So the system is a crops is not as a directly exposed to the solar radiation to minimize the discoloration and the cracking of the surface of the crop. The separate unit system unit term, that is a solar air heater, is used to crop surface used to the crop. Air heaters is used to crop heating by the hot air into the drying chamber. So separate system, that is a hot air is passing through the separate drying chamber. This is called as a drying chamber. In this drying chamber, crops or seeds are placed in that area. So just to blow through the hot air passing through the from bottom side of the drying unit. So having some of the moisture is removed, and the hot air is a moisture and moisture air and hot air to be escaping to the vent is provided for the drying unit. So the drying unit basically achieved the difference in the moisture concentration between the drying of air and the drying of the crops surface. So that is the next one is called so this is a hybrid system. So the hybrid direct solar radiation hybrid system, so solar drying system is, that is a combination of direct and indirect solar radiation. That is a combination, that is the cabin and crop, the drying unit with having a crop, both the system we are using, that is called as a hybrid system. Some of the merit of the solar system. So the solar drying technology is a simple and easy and cheaper to fabricate. So it gives a production to vegetable and fruits from the rain or insected, and hence the food stuff is free from the contamination. So drying is a faster and dried product highly hygienic and clean. The quantity of the dried product is the best. Drying is possible is throughout the year, including a rainy season with the electrical backup. So drying is uniform and retardation of uncertainty of content of the content is better. So compared with the open system, having major advantages in, that is hygienic of and clean food, and easily having a drying quantity is higher compared to open system with direct and indirect method. The indirect and direct method having a best method to drying the crop, but the cheapest method is a open system is a cheapest method. So I have discussed on that solar pond. So natural or artificial body of water for collecting, observing a solar radiation and storing as a heat. The solar pond combines a solar energy collection as well as the sensible heat storage system. The simplest of a solar pond is very shallow, about a 5 to 10 centimeter deep, with radiation of observing at bottom of the pond. A bed insulating material under the pond minimize the loss of heat to the ground. A curved cover is made of transparent or fiber glasses so over the pond, so reduce the solar radiation as well as the convection radiation losses, reduce the radiation losses as well as the convection losses. The suitable climate of all the pond water can be hot, become as a hot enough for use of space heating or agriculture or the other purpose. The water soon occurs the fairly uniform temperatures. The solar pond promises as an economical way over a flatbed collectors as a energy storage by employing a mass of water for both collection and storage of energy. So the energy is stored as a low grade as 60 degree to 100 degree Celsius in a thermal form. In itself might be suitable for a variety of applications, heatings and industrial purpose and converting of electrical energy likewise. So the first as inverted by the pond is studied and theoretical and experimental analysis as studied in the Tauber Israel Laboratory, that is a National Physical Laboratory of Israel, 1964. After it be developed some of the modification in 1968. In as a after that it will be taking as a further modification as Russian scientist in 1973. So that is a basic working principle of the solar pond. So a pond as a mass of shallow depth, shallow water about 1 to 2 meters deep with a large collection area which act as that heat trap. So it contains a dissolved salt to generate the stable density gradient. A part of instant solar radiation entering into the parts of solar surface, it will be uh, observed depth with the remainders which is penetrate the pond, observe the back of the bottom. If the pond were initially filled with the fresh waters, the lower layer would be heated up, expand and rise the surface. Because of the convective mixing, heat losses to the surface, only a small temperature rises in the pond would be realized. On the other hand, the convection can be eliminated by the initially sufficiently strong or salt gradient to be used. In this case, a thermal expansion has a hotter as a lower layer, insufficient or disability of the pond. With the convection suppressed, heat loss from the lower layer only by conducting of the convection losses. So because of the radiant relatively low conductivity, the vector act as insulators, a perimeter about as over 90 degrees Celsius to develop in a bottom layer. At the bottom of the pond, a thick, durable plastic thinner is laid. So the material used for liner include rubber or black polythene or reinforced nylon meshes. A salt like as a magnesium chloride or sodium chloride or sodium nitrate are dissolved in the waters. The concentration up to that say 20 to 30% of bottom of almost as top in the layer is almost 30. So bottom layer is at 20 to 30%, almost bottom is a 0, top of the layer is 0. So the salt gradient in the solar point dissolved salt is used to create the layer of water at a different density. More salt has the higher denser water. The concentration of salt waters at the surface is low, usually 5% can be weighted, water is relatively light. The salt concentration standardly increase the depth into unit at the bottom, whereas a high around as 20%. So the solar pond has as three different layers. So that is a one is the convective zone and gradient zone and storage zone. So that is called as a upper convective zone. That is a upper convective zone, or this is a gradient zone or non-convective zone. This is for that. Um, This is for that lower convective zone. This is the lower convective zone. So the upper convective zone, that is a depth is point upper convective zone, that is a point 3 to 0.5 meters depth. So that is a concentration of salt is up to, that is less than 5%. So this is the second one is a non-convective zone. So that the depth is 1 to 1.5 meters. It is the depth increases, that is a salt gradient also increases. So that is the last one is a storage zone or lower convective zone. So it is a 1.5 to 2 meters. So about that is a salt gradient about 20%. So normally that is a solar pond is a 2 meter depth is considers. So whereas the depth may be increases vary from 1 to 2 meters. At the bottom of the storage zone, which tropically one or more meters to be can be little half of the meters, such as several meter depth. The surface of convective zone usually a small thickness about 10 to 20 centimeters. So having a uniform concentration which is close to zero, as well as fairly uniform temperatures which is close to atmospheric temperatures, that is close to atmospheric temperatures. So the second one is a non-convective zone much thicker than that half of the depth of the pond. Both the concentration and the temperatures increases with the depth it. So it serves mainly as an insulating layer and reduce the heat losses of upward direction. This part acts as a thermal storage. The heat collection and takes places in this zone. So in the lower convective zone or otherwise storage zone, lower convective zone or otherwise a storage, comparable thickness is non-convective zones. Higher thickness is comparable to non-convective zone. Both the concentration and the temperature nearly as a constant in this zone. So it is maintain the heat collection as well as the thermal storage medium. So it serves the medium collection, this deepest zone, the more heat is stored. So the lowest zone trap the heat from the long period damping effect daily and even as a seasonal changes. This capacity of low cost storage is one of the advantages of salt gradient solar ponds. It can be tap the energy as a night as well as during the daytime. During the long period could cover or even its energy to be available. As a salty water near the bottom heat up to expand, however that can be rise because of denser that less salt of above. So the solar pond is a non-convecting warmed water stay trapped below. Some of the heat still losses by conduction to surface, but the process weakness to the convection. The lower waters as warm up to a boiling point of pure water. That is about the temperatures is about 108 degree Celsius. So depend upon the location, the water clarity and the temperature, solar pond can capture up to 10 to 20% of energy heating surface. So it have some of the salt should be some of the characteristics to be following characters of the salt material. So it have the highly valuable of solubility, allow high solution density. The solubility should not vary appreciable with the temperature. The solution must be adequatable or transferable of solar radiation. So it must be having the environmental being the handle of groundwaters. So it must have available in the absence of near to the site. So it should be delivered, the cost is low. So it must be a inexpensive. So that is a working principle of solar ponds to recover that extraction of electric energy storage system. So the energy is stored in a low grade of thermal from the lower convection zone, as a lower convection zone. The convection is due to the process heat extraction accomplished by the hot brine withdrawal of cool brine to the retention. So it is not as a practical to cover the bottom pond with any array of pipe acting as a heat exchanger due to this reason. So some of the reason that is a cost will be increases. The another one is a convection around a pipe heat transfer from the hot brine fluid will be very poor. So the extraction of thermal energy stored for lower energy can be produced easily without distribution of non-converting salt and zone above. The hot water can be extracted from the solar pond without disturbing of the convective radiance. So that is that working principles means, that is extraction means uh, where the organic fluid, working fluid we are used for the system, organic fluid we are used for the system. So the when the heat the organic fluids as the vapor as a high pressure, that the organic fluid high pressure vapor flows under the high pressure to the turbine and expanding to the that organic fluid converting as a vapor to absorb the heat and converted as a vapor and expanded in a turbine. So the turbine is coupled with generators. The generator produces electricity. The expand vapor goes to the condenser. So the condenser condensate, that is organic fluid by a form of a liquid, then goes to the heat exchangers. So this a cycle is repeated. That is a heated waters. That is a heated waters goes to the evaporator or boiler. That is heat will be exchangers to be here. The organic fluid converted into a vapors. So it will be, the cycle will be repeatedly goes to the entire cycling process. So it record for produces to maximum, it will be taking as a 20 kilowatt. It records for a 2000 square feet record for the producing of 20 kilometer of 20 kilowatt it will be produced for electrical energies.